Hey Steph, it's Friday. I've been watching Cosmos, a science documentary series hosted by the amazing Neil deGrasse Tyson.
Pick a layer. Any layer.
It's my favorite show on the air right now, and it's definitely something you should check out. With last Sunday's episode about Michael Faraday and the discovery of electromagnetism,
don't try this at home.
As well as spring being in the air, I wanted to talk a little bit today about our sun. So it keeps us alive and well supplied with energy, but it also got a dark side to it. Not literally, it's actually all really extremely bright. For a long time, people have been familiar with the fact that the sun in our sky is the main reason that there's life on Earth today. Cultures around the world have had sun gods or have viewed the sun as a deity for thousands, if not tens of thousands of years. Our sun is currently about 100 million miles away from the Earth, but that's nothing in space. It's more than capable of setting our species back a few centuries if the right conditions come up. Right now, the sun is actually near the peak of an 11-year cycle of solar activity. In February of this year, the sun flared up and spewed millions of tons of material from its surface. Scientists actually have a name for this kind of thing. They call it a coronal mass ejection. The corona is basically the outer layer of the sun. It's what you see during a total solar eclipse, and that's why you're able to look at it, because it's much less bright than the whole sun itself. So if this February's coronal mass ejection had been directed towards Earth instead of out in space, it was aimed just off to the side of us, so it wasn't at us directly. That's entirely unpredictable. It almost certainly would have caused major problems with satellites, as well as sensitive electronics and our electric grid here on Earth. So there have been major power disruptions as well as blackouts caused by solar storms in the past. And with our current technology, there's really nothing we can do to prevent it or to stop damage from happening to our planet, and especially us and our electronics. So to explain how and why this happens, it's important to understand what's happening inside our sun, as well as how that affects the way we are today. First, the sun, as well as every other star in the universe, is powered by a massive nuclear furnace. So it turns light elements like hydrogen into heavier atoms like helium, as well as elements that are important to life on Earth, like carbon and oxygen. As a result of these intense chemical reactions, all kinds of energy is given off by the sun and the other stars. You got radio waves, Wi-Fi, microwaves, heat, visible light, UV rays, X-rays, gamma rays. These are all different examples of light that have different amounts of energy. And basically, the sun and all the stars radiate massive quantities of all of these kinds of waves all the time. They have for billions of years, and they will continue to for billions of years in the future. So basically, the more energy a particle of light has, the more likely it is to do damage to a human or to sensitive electronics, like those found in computers, cell phones, and our electric grid. So basically, when the sun undergoes a mass coronal ejection, which is different from light, it's the actual physical ejection of sun material, huge bursts of this light radiation are going to go as well. And since light travels faster than anything else, it's actually going to get to Earth well before the material. It's going to take about 8 minutes to get from the sun to the Earth. And so that's our first sign that something bad is happening, that there's been a coronal mass ejection, is because light is going to arrive from the sun. It's a lot more powerful, a lot brighter than the sun normally is. So the particles themselves that do come along with this, they're traveling extremely quickly as well. A couple thousand kilometers per second is the top speed that was measured in February. But this is actually still 150 times slower than light. And so even though it's thousands of kilometers per second, it's still going to take a day or two to get here from the sun. As well, most of the light and the particles in light are basically ejected from the sun all the time. The difference between this and a coronal mass ejection is the amount of particles and the amount of light that's ejected by the sun. And so normally, most of these particles, most of the light is trapped or deflected by our magnetic field at the Earth for the particles and by our atmosphere for the light. But in a severe storm, some of these particles and some of the light is going to make it through nature's defenses, and these particles can actually interfere with DNA in people. For the light, especially gamma rays, X-rays, it's what's called ionizing radiation, and that can do a lot of damage. And the particles themselves can also impact circuits, as well as different gadgets and stuff that we have, electronics. So these particle storms, basically the coronal mass ejections, when they do hit the Earth, That's actually what causes the aurora borealis, as well as that's in the north, and the aurora australis in the south. It's these charged particles interacting with our atmosphere. So that's really cool. And those interactions actually generate light as well, and we see that as visible light. It's usually green or red. On the bright side, our sun is actually extremely stable. And unless we continue to destroy our planet and the defenses like the ozone layer that exist around us, the sun's going to continue to shine brightly and consistently for us for billions of years. And that's actually long after life on our planet will have ceased to exist. The sun eventually will grow into a red giant and probably swallow us, but that's going to be billions of years. There's not going to be life left on our planet. Hopefully we'll be able to survive, but we will have to move to another planet or move to another galaxy. In a way, to me, that's actually comforting. Anyways, that's it. I hope you learned something today, and I hope basically you and anybody else watching this stops taking what we have on Earth for granted, stops destroying the ozone layer, stops deforesting, which is as well as pumping carbon dioxide into the atmosphere, which is causing a greenhouse effect. It's going to cause the Earth to heat up. We need to start doing what we can to keep humanity, as well as life on Earth, going for a long, long time, no matter what the sun says. I love you, and I'll see you Wednesday.